Thyristor firing circuits or gate pulse generating circuits. Thyristor converters have different potentials at various terminals, whereas the supply is given will be in hundreds of volts and the gate pulse is near about 12 to 30 volts. An isolation circuit is required between individual thyristor and gate pulse generating circuit, and this isolation can be accomplished by using pulse transformers or optocouplers. An optocoupler could be phototransistor or photo SCR. Here we can see two types of gate pulse generator circuits or isolators. This is a photo SCR coupled isolator and this is a pulse transformer isolator. A short pulse to the input of an infrared light emitting diode D1 is given. It turns on the photo SCR T1 and the power thyristor TL is triggered. This type of isolation requires a separate power VCC and increases the cost and weight of the firing circuit. Whereas this is the simplest arrangement of isolation with pulse transformer having a short pulse. When the short pulse V1 is given to the base of the transistor Q1, then Q1 turns on. When this turns on, the VCC is going to appear across the winding of N1 and this voltage is going to induce a voltage in N2. Gate pulse is generated in a short pulse. When this input voltage is 0, the Q1 is going to turn off. Q1 is going to off. The thyristor is going to off. Then the negative or reverse voltage is going to flow through the diode DM, that is freewheeling diode, back to VCC. The current due to the transformer magnetic energy decays through DM to 0. During this transition decay, a corresponding reverse voltage is induced in the secondary, that is a negative or reverse voltage. This is how the pulse is generated in pulse transformer in short pulse. The pulse width can be made longer by connecting capacitor C across the resistor R like this. Then the output pulse will be, this is our gate pulse now after modification. Then we are going to get long pulse. The transformer carries unidirectional current and the magnetic core will be saturated, thereby limiting the pulse width. This type of pulse isolation is suitable for pulses of 50 microseconds to 100 microseconds. In many power converters with inductive loads, the conduction period of a thyristor depends on the load factor, and the beginning of the thyristor conduction is not well defined. In that situation, it is often necessary to trigger the thyristor continuously. However, a continuous gating increases thyristor losses. A pulse train, which is preferable, can be obtained with an auxiliary windings as shown in the pulse train generator. This is our auxiliary winding. When Q1 is turned on, a voltage is induced in the auxiliary winding N3 at the base of the transistor Q1 such that the diode D1 is reverse biased and Q1 turns off. In the meantime, the capacitor C1 charges through the R1, turns on the Q1 again. This process of turn on and turn off continues as long as there is an input signal V1 to the isolator. When this Q1 is turned on, the voltage is going to appear across the N1 that induces voltage in N2, that is nothing but the gate voltage. Due to this turn on turn off repetition process, the gate voltage will be like a pulse of train. Instead of using auxiliary winding as a blocking oscillator, an AND gate with oscillator could generate a pulse train. This oscillator is again a timer. When Q1 is turned on, the voltage is going to induce N1 and generates a pulse. When Q1 is off, the pulse is off at the gate voltage. To turn on the Q1, when V1 is given and V2 is present, then the output of AND gate is present. Then that is going to turn on the Q1. When this oscillator or timer voltage is 0, the output of the AND gate is also 0 and that is going to turn off the Q1. This process repeats, depends on the timer and the voltage. When these two signals are present, the output of AND gate is present and that is going to turn on the Q1. That is how the gate voltage or gate pulse is generated in this circuit. In practice, the AND gate cannot drive transistor Q1 directly, and a buffer stage is normally connected before the thyristor. These two pulse generators are used when the converter is connected to a load having inductor or inductive load, where the continuous pulse signal is required. Gate protection circuit. The output of gate circuit is normally connected between the gate and cathode along with other gate protecting components. The resistor Rg. The resistor Rg increases dV by dt capability, reduces turn off time, and increases holding and latching currents. And the protective component capacitor Cg removes high frequency noise components and increases dV by dt capability and gate delay time. And the protecting component diode Dg protects gate from negative voltages. However, for asymmetrical SCRs, it is desirable to have some amount of negative gate voltage to improve the dV by dt capability and also to reduce the turn off time. All these features combined with diode D1 and resistance R1. D1 allows only positive pulse and R1 damps out any transient oscillation and limits gate current. This is a gate protecting circuit to have all these advantages and protect the gate.